Coral reefs are beautiful and valuable ecosystems, but they are vulnerable to changes in their environment. Understanding how climate change and human activities affect these ecosystems requires comparing current conditions with those in the past. Unfortunately, this historical information is often unknown. One way to learn about the past is by examining the geological record in coral skeletons to find clues about past climatic and environmental conditions. maCoBioS scientists are using these techniques to study changes in the Caribbean and Mediterranean seas associated with the current climatic and local environmental changes.
Paleoclimatology is the study of the past climate and environmental conditions. What we do is reconstruct past environmental and climate conditions using natural archive.
So the data we find out about past climate change, they help us to calibrate models for a regional or global climate change. There is ice cores, there is tree rings, there is glacier records and so on. But in the tropics, there is little information about past climate change.
In this case, we're using the skeletons of corals as indicators of different environmental parameters like sea surface temperature, pH, terrestrial runoff. By using these paleo records, we extend the natural information, and the idea is to look how anthropogenic activities have impacted the reef. So we look at corals over several decades or even centuries.
Another challenge is related to the actual sampling underwater. So this takes quite some time because the corals we are sampling, the Siderastrea siderea, these are very dense, so they are difficult to drill. So we have very slow progress while we are drilling. So, for example, a core like this with 30 centimeters, that takes 1 hour 30 minutes at least, continuous drilling underwater. So it's a hard work.
So once we collect these cores, we clean them, we take them into special labs, and the first is to get slabs out of them. So we cut along the growth, the axis of growth of the colony, and we get different types of information. We do this by taking X-rays of the slabs, and that reveals the density bands, which are normally annual in nature, and that allows us to actually count the number of years in the record, and also to extract information about the growth rates, how fast the coral grows.
So the second part involves doing geochemistry. Corals archive elements into the skeletons during the calcification process, which can reflect specific environmental parameters. So for instance, it is possible to reconstruct coastal sedimentation and understand its influence on the coral individual performance, which can aid the definition of priority areas for conservation.
In the project maCoBioS, researchers have collected coral cores from Martinique and Bonaire to reveal invaluable information about past climates and environmental changes spanning decades to centuries. By analysing growth patterns and chemical compositions within these cores, scientists uncover secrets about the ocean's history, aiding in climate change research and understanding the impacts of human activities on reef health.
As part of my PhD project, I'm using skeletal growth bands to reconstruct the growth rates of Siderastrea siderea corals from Martinique. And what we found so far is that past local human activities impacted these corals before bleaching events, and that current warming trends push them beyond their optimum for calcification. This basically means that current temperatures are making it more difficult for corals to construct their skeletons.